All right, today we're going to be covering lesson 7-1, the spring experiment. This lesson is going to be separated into four sections. The four sections will cover questions 1 to 7, 8 to 10, 11 to 16, and 17 to 19. Now, it starts off by telling us that we're going to do this experiment, but because of COVID restrictions, we're not going to be able to do the experiment. So I've crossed through the top part where it leads into the experiment in question 1. So I have actually given you data for number 2. What happens is we have this cup set up here. And what we would do is we would drop little, I actually use big pink erasers whenever I do this experiment. And I drop them into the cup and we see how far the rubber band stretches. Okay. So here I've given you some data. Well, with one eraser that I would use, okay, I would have a stretch of 2. Whenever I put that second eraser in, I have a stretch of 4. Here, the rubber band is going to stretch 6 at 3. It's going to stretch to 8 at 4. And with 5 washers, it's going to stretch to 10. Okay? It says, what patterns do you notice that might help you determine the relationship between the number of washers in the cup and the length of the rubber band stretch? Well, it looks to me for every washer, placed in the cup, the stretch is increased by 2. I also noticed that if I take the number of washers and I multiply by 2, I'm getting that same combination. So I'm going to put, how do I want to write this? Washer times 2 equals the stretch. Move over to question number 4. It's on the next page. Here, number 4 states, use your table to make a graph. Be sure to label the appropriate scale on the X and Y axis. Oh, sorry. They've already numbered the washers at the bottom for me, but let's talk about the length of stretch. Well, let's go up by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, and if I had to do 10, it would be kind of up here, right? And so at one washer, we say that the stretch is 2. So to do that, I'm going to go over to 1, up to 2, and I'm going to plot a point. Then we're going to go over to 2, up to 4, because that was my second. Then I got 3, 6. So 3 washers. Sorry, I'm trying to give us some space here. 3 washers, and it was 6 on your stretch. We've got 4 washers, would have been a stretch of 8. And 5 washers would be kind of right off the grid up there at 10, right? Let's take a look at 5. Describe your graph. What do you notice here? What's our graph look like? Yeah, our graph is a line. It should resemble a line. Model with mathematics. Use your graph and any patterns you described in item 3 to write an equation that describes the relationship between the number of washers and the length of the stretch. So if I were to write an equation based on what I noted in question number 3, I said every washer is increased by 2, right? So, and I even noted washer times 2 equals my stretch. Well, my stretch here is my y. So whenever I go to write this, I'm going to write, it says write an equation. So I'm going to write y equals, now for every single washer, and my number of washers is x, right? We know that it increases by 2. So we're going to do 2 times x gives me y. Use your graph or your equation to predict the length of the stretch for 8 washers and for 10 washers. Now, we could use the graph, but my problem is whenever I created my graph, whenever I did my scale actually went off and I can't plot anymore. So I'm going to actually go back to the equation we just created. I'm going to go y equals 2 times 8. That gives me 16 stretch of 16, sorry. And then for 10, I got y equals 2 times 10, and that's going to be a stretch of 20. On to your debriefing question for this section.